Okay, so let's look at lab 3. We continue our work with conventional ICs, designing combinational logic. It will take too long for me to show you every step. I trust that by this time you guys have some level of skill and expertise to be able to wire up these integrated circuits. I have made a few labels for you here. For instance, here's the truth table for the output at J, right? This will be J output right here. Okay, I also have three more partial outputs, and the other outputs are this one right here, which is going to be A not C, and then the other output is going to be A B, the other output is going to be not A. Those are the actual outputs at every stage of the circuit. Once you have the information, for example, one digitalized schematic, you will know what I'm talking about. Hopefully you have it by this time. If not, you're going to be trying to guess. But yeah, have on your hand the example for lab number 3, page 26, and you understand what we're doing. So that's the truth table. Those are the partial outputs. These are the input pin numbers that I have designed. For instance, pin 1 right here on the 08 is going to be input B. Pin 2 is going to be input A on the 7408, and pin 5 is going to be C, right? That's how that's figured out. All right, let's go ahead and run this. Again, if you're looking at the table, you probably will have a better idea. But as I start this out at count 0, right, J output is 0, but the A naught output is high, right? The A naught output is high, and that's the only one that should be high. Now I'm going to start the count, and I'm going to set up this to 1, 0, 1. And as I run 1, 0, 1, now I have that J is high, A naught C is high, and A naught is high, right? So again, these are the actual outputs. I should label them. Hopefully you understand what I'm talking about. So A naught is this first output, A B is the second output, A naught C is the third output, and J is the actually fourth output. It was hard for me to organize all this here, but anyway, that's count of 1. Let's set up this count to 2 and see what happens. 2 provides only the not output high. Let's do this to 3. 3 gives a count of J and A not C high, and also A not high. All right, that was 3. Then we're going to do 4. All right, 4. Count of 4 turns everything off, right? And that's what the schematic is saying, right? That when the count is 4, you see right here, this count right here, everything's going to be 0, right? And then 5, likewise, 5 also gives 0, 0. And then the next count is going to be 6. 6 turns on both A, B, and J. And then finally, the count of 7. 7 turns on both A, B, and J. And there you go. That actually is example 1. You are to build all of these circuits both in Tinkercad for pre-lab and in actual hardware for the actual lab. I might be able to give you some help, but this should not be anything complicated. You can work it out. You already have some expertise. Just wanted to give you some heads up on how you can get started. And I'll share this file with you so you can modify it if you want, and you can go from there, okay? Let me know if you have any questions. Thank you.